Revolutionary advancements in intelligence have been made in the past few decades. Computers that can recognize human speech, a machine so powerful it can defeat the world's best Go players, and the ability to predict what we're about to say or type now exist in our world. But how did we do that? Well, it's all based on a very simple idea that can be applied almost anywhere we want high performance, and that idea is optimization. It's seriously hard to find anything that cannot benefit from this idea because it's all about making something, anything, the best that it can be, which is very useful, don't you think? Let's say you're opening up a shop in the city of Cartesia. Where's the best place to put it? Well, you don't want your potential customers to have to walk too far, so you might want to minimize the average distance someone would need to travel to get to your store. And indeed, all optimization problems can be thought of as finding the minimum possible value of some expression. We can represent this problem with you on this 3D surface, where your elevation above a point is the average distance one of these people would have to travel if your store were placed there. So our goal is to find where the lowest point on this surface is. We can see that if you're at a sloped part of the surface, then somewhere around you leads to a lower place, which means a better shop location. So you should keep moving until you reach flat ground. This idea of repeatedly moving in a direction that takes us downhill is known as gradient descent. The gradient from calculus and linear algebra to fundamental fields of higher math is what can tell us the steepest downhill direction at any point in space, so that we can perform a descent by moving in that direction. So how did AlphaGo beat the best Go player in the world? Obviously it used a really good strategy. But how did it learn that strategy? The key is that strategies for doing anything at all can be encoded as a bunch of numbers, and can therefore also be optimized just like we did with the shop, although computers do it in a much higher dimensional space. All we need is a way to evaluate how good or bad a strategy is. In the case of AlphaGo, it played millions of games against itself using different strategies, and the more a strategy won, the better it was considered to be. But why computers? Why not just solve directly for the minimum like we do in math class? Well, strategies that are very elaborate need thousands or even millions of numbers to encode, and solving for the optimal combination of a million numbers is almost impossible. Instead, it's much easier to start somewhere and then optimize little by little. It's similar to how we as humans learn something new, like a sport. We start with whatever skill we have and improve from there. The historic win of AlphaGo over Lee Sedol showed that computers, just like us, have lots more potential to be unlocked. The possibilities are truly endless. Back when Newton and Leibniz invented calculus, the math underlying traditional optimization, the power that computers have today was unimaginable, and with science developing so quickly, who knows what will come next? But one thing's for sure, as we continue to make breakthroughs, optimization will play a key role in making the world a better place. Thanks for watching.